Okay, good. All right, so we're going to talk about word problems today. Word problems, as I mentioned just a little while ago, they can be very confusing. And even math teachers get confused with word problems. We have to think about it, and we have to read it. Sometimes I have to read a problem 5 times before I even know what they're asking me to do, right? And even then, I don't know quite how to solve it yet, and I have to sort of figure it out. Now, I'm going to be teaching you certain types of word problems, and in this particular case today, it's going to be motion word problems with the idea that you'll start to get comfortable with different types of problems. And by getting comfortable with those types of problems, I think it will just make word problems in general easier. You know, because you'll see something and you'll think, oh, that reminds me of motion word problems. Maybe that's how I solve it. Or that reminds me of consecutive integer word problems, or whatever. So first of all, let's just talk about the formula that you're going to use. And this is the formula. It's R, let's see, how far can I go? Pretty quick. R times D, oh, wait, what am I doing? Rate times time. R times T equals D. And R stands for rate. Okay, we'll just do this. Rate times time equals distance. Did it work? Okay. Rate times time equals distance. That's what the R, T, and D stand for, okay? And let's just talk about what is a time. Give me an example of a time.
43 minutes.
What? 7:30 what?
8.
So, meaning amount of time it might take to drive somewhere.
Oh, 37.
So, Bella.
37 minutes.
37 minutes. Okay, so time, an example of time could be 37 minutes. So you have to have something. Okay, what if it's very quick? What could be what's smaller than minutes? All right, we could have 2 seconds, right? Or what's a little longer than minutes? What would it be?
Hours.
4 hours.
It could be 10 hours, right?
9 days.
Or it could be days, right?
What
Or
about
it could be months or weeks or whatever, right? Could
Years.
be lots of things.
Millennium.
Most of the
Decades.
time in these problems,
Light speeds.
That's not.
I know.
okay, guys, most of the time in these problems, it's going to be hours or minutes. Seldom is it going to be seconds, but most of the time it's going to be hours and minutes. Most of the time it's going to be hours. And then, so then let's talk about rates. What are rates? Give me an example of a rate. Does anybody know what a rate is?
Like if you're going like 20 miles per hour.
20 miles per hour. Rate is, can you think of another word for rate?
How far? MPH.
Not how far, because that would be distance, right?
Rate would be how fast you're going.
How fast, your speed, right? So rate is the same thing as speed,
So
right? And if you're in your car, your parents' car, and your parents are driving, how fast might they be going on the highway?
85 miles per hour.
So okay, we'll say 85 mph, right? Immediately when you see miles per hour, you know you're talking about hours, right? So your time should probably be in hours. Does that make sense? If you're talking about miles per hour, you want your times to be in hours. You don't want it to be in minutes. And if they're in minutes, you have to convert them to hours. But I'm not going to make it that hard on you guys. When I say miles per hour, my times are already going to be in just hours. Does that make sense? If I said feet per second or yards per second, I think there's one problem on the homework where I said yards per second. Yards per second is a rate, right? A yard, meaning I'm going 3 feet per second, right? Every second I'm going 1 yard or 3
Couldn't
feet.
you convert that to hours?
I could, totally.
That would
Yeah.
be hard though.
It wouldn't be hard, but
If you just multiply, you figure out how many minutes are in an hour and then do that. 60 minutes in an hour and then.
But there's 3 yards and
Right, but you're only figuring out yards per hour. You're not figuring out miles.
so yeah, good question. But we'll do that another time. But for now, I'm going to keep it simple. But you're going to see miles per hour or yards per second or something. It's a distance, right? Miles or distance. Miles or yards or distance, right? Hours or time. Miles per hour is distance per time. That is called a rate. That's how fast you go. That's a speed, okay? So, all right, just so you understand those things. And distance, you guys know what distance is, right? It's like, my house is 10 miles away, right? Your house is 5 miles away, whatever, you know? So it's just, it's a distance. Okay, so now, the best way to solve these is to figure out a way to pull the information together in a useful way. Because right now, it's a big gobbledygoosh, you know, of stuff, of words. And so I'm gonna create a box, and I'm gonna label it as rate times time equals distance. R times T equals D. And I'm gonna put a box underneath this. Okay? And I'm gonna, how many trains do we have?
2.
2. So I'm gonna make 2 rows, like this. Okay? Make sure this is in your notes. And then I'm gonna draw a line here so that I separate my rate from my time from my distance. All right? This box method is priceless. So John, be sure you're writing this down. Or if you want, if you'd rather, you can take pictures. Do you have your phone with you? You can go get your phone if you want and take pictures. So, how many trains we have? How do I identify the difference between?
Northbound and southbound.
Okay, so I'll say the north train, right, and the south train. Okay, that helps me, so I can identify which is which. Now it's just I just read through the problem. Do you have a question, Skylar?
Wouldn't we be finding the time?
Yeah, if you look at the very last question, why don't I just read the whole thing? 2 trains leave the station, the same station, right? At the same time. Right at the same time they leave. One is going this way, north. One of them's going south, right?
Very nice, Karen.
Right? Right? And they're traveling in opposite directions. That makes sense. Opposite directions. The northbound train is going 125 miles per hour. What is that? Is that a rate or a time or a distance?
Rate.
That's a rate. And the southbound train goes 120 miles per hour,
Rate.
another rate. After, here's the final question. After how long? What does how long mean? Time. They're asking us to find the time.
Oh,
Exactly.
oh, I have
After how long will they be, what is this? 735, that's a distance, okay,
Gary,
miles apart.
T, to find time you do T equals D over
Okay.
R.
Okay, hang on. I'm gonna just focus on the lecture today. So 2 trains leave the station, so I've got to figure out what is my northbound train's rate?
120.
The rate is
125 miles per hour.
Yeah, it says the northbound train goes 125 miles per hour. So does everybody agree with me that I put 125 here?
Yeah.
Yep.
Because that's what it says. The northbound train goes 125 miles, this is north
You
train.
have to put MPH.
That's rate. You don't have to put MPH.
Should
in your-
you put MPH?
No, not in your box.
Well, why not? It doesn't matter.
And the southbound train goes 120 miles per hour, right? So wouldn't you agree with me? I'd put 120 here? Yes?
Yes.
Now, I don't know the distance. Do I know the distance that the northbound train goes? What is it?
735 miles.
No,
Well,
no, no.
think about
That's
it.
both of them
Divided by 2.
Well, but we don't know if it's divided by 2 would mean each one would be going exactly the same speed.
Yeah, and one's going 5 miles
Does
faster.
that make sense?
But-
It's a really good idea, Bella.
Does the,
So that's not gonna work. So this is what I'm gonna suggest. We're gonna put a third box down here for our total distance. This is our total distance, okay? This is gonna be the 735 miles, okay? That make sense? So, well, it does make sense, but it will in a second. All right, but what are we
Now
missing?
don't have enough information.
The time is the problem. Do you agree with me?
So it's X.
So we don't know what, we don't know what time is. So we definitely want to make time X if we can. The question is the time the same for both of the trains? Okay, let's think about it. they leave the station. Can I just pretend like that's north and that's south? Is that
Yes.
okay? So I'm not going like this.
I don't know which way.
I'd rather-
which, so yes.
Yeah, so maybe,
Actually, it probably is, Gary.
oh,
like-
maybe that is north and that's south. So, okay,
Yeah.
that's great, great. That'll make it easier for me. So, the trains leave at exactly the same time, right? And they're going in this direction, away from each other, directly away from each other. And we're measuring the distance between the two, and when they get to 735 miles, they stop. So is the time the same for both trains?
Yeah.
They leave at the same time. Do you agree with me?
But one's going
And
down.
right, but that doesn't matter. They stop at the same time because they get 730. Do you agree with me? That
Yeah.
the time is the same. They start at the same time. They stop at the same time.
Yeah.
Time is the same. So I could make them both x. You agree with me? Okay, now how do you find D? You have a formula. Look at your formula. Rate
Oh,
times time
so it's
equals
Times
distance.
125.
It's
X
125
X.
So it's just going to be this times this. And 125 times an unknown is 125 the unknown, x. And how would I find the distance for the second one?
120x.
120x. Beautiful. Okay. So now we have this box, and we filled it all out. You guys agree with me?
Yeah.
Does it make sense a little bit?
No.
It's going to make sense in a second, because what Bella's noticing is we don't have a way, we don't know what to do with this information, right?
Yes.
So this is the key, is understand, let's draw our picture for a second. This is the station, okay? Right there is the station. And one train, they both leave at the same time. This one goes this far this way. This one goes this far this way. All right? Clearly one's going to be shorter and one's going to be longer. You guys agree with me? So, what is the distance when they're done? The final distance?
735.
We know all the way from here to here is going to be 735, right? That's 735 miles. Right? This is a distance of one train. We'll call this D1. Distance 1. And from here to here is distance 2. Do you guys agree with me? Each train has their own, distance 2. Each train has their own distance. I don't know what it is, but I know what kind of equation could I create from this picture?
Why can't you just do 25x and 20x? What was I gonna say? Like,
Divide 735 by that?
yeah.
Say what again?
Divide 735 by 120x is 125x.
Wouldn't that be easier to do?
Divide 735 by 120x
No,
and
the other way around.
120x by 735.
Or whatever way it works.
Okay,
You want to get x alone, so it's x equals.
true. Okay, but this is what I'm going to suggest. Wouldn't you agree with me that this distance of this train plus this distance of this train would equal the total distance?
Yeah, but we don't know it.
Doesn't that make sense? Yeah.
That makes sense.
All right, so let's,
120.
so really what we're saying is D1 plus D2 is equal to the total distance, right?
So 125x plus 120x equals 735, and then you just
Right,
solve it
so
like
here you
that.
go. You've got, this is your D1, right? And then this is your D2, and this is your total distance. So this plus this equals this. So when you set this up like this, in this box, you immediately know it's this one plus this one equals this one, right? Your total distance is always down here, just outside the box. Your two distances, you have to add them together to get this. So now, I'm going to erase this mess.
It doesn't equal though.
Well, it may or may not. I don't know. I haven't done it yet. So we're going to do 125x plus 120x equals 735. I know that's got to be true. So what is that? 145?
200.
I'm sorry, 245?
Yeah.
245x is equal to 735. Now, what would I do to solve for x? Divide by 245. Divide by 245. Okay, so, and on these, you're welcome to use your calculator, okay? So, 735 divided by 245 equals 3. Oh my gosh, x equals 3.
Oh, so the time is, wait, but we don't, what?
3 hours.
Oh, because it's miles per hour and the rate is miles
Right.
per hour and the distance.
Since we
is
know the rate is miles per hour, we know our time is in hours. So we just solved 3 hours. So in 3 hours, train number,
What?
well, the two trains will be 735 miles apart. Does that make sense?
No.
No.
Yes, it does.
That last part doesn't make sense.
Okay, which
Once
part?
you got X, nothing.
All right, so do you understand the equation that 125x
Yeah.
plus
Anything
120x equals 735?
Yeah, I got X and stuff.
And that you understand that x equals
Yeah.
3?
Yeah.
All right, so x is your, look at your box now. See, your box tells you what x is. X is your time. And we know it's in hours because these are in miles per hour. The rates are miles per hour, distance per hour. So we know the time is in hours. So when we solved x equals 3, we're saying time is equal to 3 hours. Okay? Is that clear, fella? Does that make sense? We're going to do another one, and just to practice. This is just the teaching one. Then we're going to practice one. Okay? And so my final answer, am I done?
Yes.
No.
Well, no, you have to write in 3 hours the train.
They will be.
Yeah, I have to write it out in words because they asked it in words, so I have to answer in words. In 3 hours, 3 hours.
Is it possible just to say they will meet in 3 hours? Or like 3 hours?
It'll be 700.
Can you write the trains will be 3 hours? Or no, they will
Like,
be
what's the
735 miles per hour in 3 hours.
I know, I'm trying to think of the shortest way to possibly say that. So can you just write 3 hours?
I would be okay with just saying in 3 hours and putting a box around that.
Okay, because like,
I would be fine with that.
if
Some
the teacher
teachers-
asks you like, after how long will they be in
Yeah.
the blah, blah, you can just be like,
I would be fine
3
with
hours.
just in 3 hours.
Unless you're a Latin,
Okay.
you're a Latin person, you don't have to say in 3 hours they will be.
The thing is, different teachers will require different things. Some teachers will say, no, you have to give me a full sentence. I'm not saying you need a full sentence, but some teachers will. And
Alright.
I'll mark you off. Okay.
Can you do one with a shorter writing part at the beginning?
Well, I'll try. Okay, so can I erase this? Now, John, go get your phone so you can take a picture of this, okay?
Can I take a picture just in case?
John, go get
So
your
while
phone.
he's getting, and if anybody else needs to take a picture, that's fine too, okay?
I
um,
will.
So let's just review what we did. We read the problem. Let's just review really fast. We read the problem. We saw that there are two trains are going in, they're starting at the same time, they're ending at the same time. They're, sorry, let me get out of your way.
Fall over.
Um,
How do you know that they're stopping? Like, if they just keep, it's just asking if they're, when they're not
right.
actually
They're
stopping.
not
but
necessarily
just like
stopping,
this.
but I'm saying that clock is stopping because that's what we're asking for. Do you see what I mean?
Alright, come on, get ready.
Okay.
Do another one before we run out.
Okay, we got some
We
time.
have plenty of time on the app.
No.
It's 11:23.
Got it?
Did you see how long that probably took?
Okay, next one. Let's just erase this. Get ready to write.
Take that into consideration.
All right, I think as we do, we're gonna do maybe 2 or 3. Or two, maybe 2 more. We'll see. This is number 2. And once you get the hang of them, they're actually fun. Okay,
Or are
Fun or ours?
Well, I love linear systems.
Yeah, they're
And then
Okay,
I
John
I don't like it.
and Sue
I don't like it.
live
John and Sue.
810.
1 and 2.
Oh wait, hang on a second.
800
Juan and who?
Hang on a second. I don't know if I want to scare you. Well, that's okay.
Gary, scare us. We'll be fine.
Obi-Wan Kenobi.
I will.
Obi-Wan Kenobi.
I'm Juan Papa.
Okay, John and Sue live 810 miles apart. If
They have a zip line connecting their two houses.
they
Have a zip line. Let's use a zip line.
leave,
Oh.
okay,
On the zip line connecting their two houses, how
At
long does it take for
the
them to get together?
okay guys, so Skylar.
Nobody
write.
cares because they're gonna be dead.
So guys, please start writing. You should be writing right now. Okay? Leave at, okay. Where am I? If they, where am I?
That's actually pretty far. Like that's
At-
like
If they leave at the same time and drive
it's like 5 hours.
towards each other,
They're gonna die.
And I never know how to spell cord.
Go with it, Amaya.
Cords. I spelled it wrong. Or they can crash into each other and roll off a bridge.
That would
With-
take like 5 hours
Why
because
is everybody so morbid?
driving from here to El Paso is 4 hours and that's 700 miles.
Well, we don't know how fast they're going.
okay guys, focus on writing.
But we can't hear you, we
Guys.
can't see it.
Guys, focus on writing. Okay, okay, with John driving at 55 miles per hour and Sue driving at 80 miles per hour,
She's speeding.
Not
comma,
on the snow jumps, it's really slow.
after how many hours will they meet?
Well, you're done too.
After how?
Maybe the speed limit near John's house is 55 miles per hour, and near Sue's house is 80.
Well, if it were like 75 miles per hour, she wouldn't be
After
speeding.
how many hours?
If it were like 75 miles where she lives, that's not speeding. 5
So
miles is
Jacob,
speeding.
can you write, please?
We don't know. Why can't
Math,
speak English? I know, right? Can you please just give us like the formula so we don't have to like solve it all the
No, like, but I
Okay, so I'm gonna assume that because people are talking that we're done writing. So we're gonna just go. So John and Sue, we're gonna read the problem together. Okay, John and Sue live 810 miles apart. If they leave at exactly the same time, this is just a little different, right? Before they were together and they left at the same time and went away from each other.
But it's still the same thing.
But now they're away from each other, but they're leaving at the same time and they're driving
the
towards
same.
each other. It's the same thing, right? It's the same thing because this distance plus this distance is going to equal the total distance. Does that make sense? This distance plus this distance has got to equal the total distance. Do you agree with me?
It's 6 hours.
So it's D1 plus D2, right? In this case, they're starting here and here. They're driving towards each other. And when they hit here,
Well, when they hit,
they will have gone 810 miles.
is gonna hit way like closer to the other one's house.
Right, exactly, exactly.
He will, because, wait, no.
Yeah, yeah. Sue
Now-
will. Oh no, Sue will.
Sue will, because she's going
But if
faster.
they're closer to a hospital.
She'll
Okay.
be closer to his house because she's going faster.
All right, so let's do our box again, right?
gonna be like,
Clearly, okay, guys, this is a video, guys, so please. Clearly, it's going to be our rate times time equals distance again. So we're going to write our rate times time equals distance. And we're going to draw our box. And we have 2 cars. So we have 2 rows. And we're going to split them up into columns. And I know one of them is John, so I'm going to put John. And the other one is Sue. I'm going to put Sue there. And now I just fill in everything into the box, right? So Jax, tell me something I can fill in. So John is driving at 55 miles per hour. Where would I put that? Miles per hour. That's speed. That's rate. Right? Time would be just
55.
hours. You see the difference? Yeah. So it would be this. So it would be 55 And then somebody else, Sue. Yes.
80.
80. Okay, Sue's going 80, right? Now their time.
X.
They're leaving at exactly the same time, and they're
X.
crashing at exactly the same time,
X.
right? Right? So X. They're not crashing. They're just
Yay!
they're doing a high five as they drive by.
That would be painful.
I thought they were meeting
They
at a
would
coffee
rip
place
off
that's
their
exactly
arms.
there.
Now, am I missing what about this little box down here? Don't I need this?
Yes, that's
What would go there? Bella, what would go in this box here?
8, 10.
Yes, exactly. 8, 10. So what would I put here now?
55x.
It's going to be rate times time. So it's 55 times x or 55x.
I solved it.
80x, right? Everybody gets this? 80x. All right, so what's my final equation, Skylar?
55x plus 80x equals 810.
Say it again?
55x plus 80x equals 810.
Equals 810. I agree with that. It's this plus this equals this.
Yeah.
Really quite easy, right? So now we're going to add them together. What is 80 plus?
135.
Thank you. 135x
Who knows, right?
equals 810. Divide by 135. Divide by 135.
6.
X is equal to, is it really?
Yeah.
Yeah, you got it right.
Yay, I'm did it.
6. Those 5 is 30, 6, 18, 19, 20, yeah.
Yeah, I got that in
Yeah,
that
you're right.
video.
6. Great. So what's my final answer?
6 hours.
All right, so we'll do it our short way. We'll say in 6 hours.
Thank you.
In 6 minutes.
If you just wrote 6 hours,
In 6 hours.
you have to write in, Gary.
Gary, can I use the
What?
Yes.
It's like 6 hours and your arm is gone.
Wait, Gary, you have to write in, and you just like,
binary, you gotta answer it.
She just write 6.
So how are you guys feeling with this?
like 6H. Could you just write 6?
So how, no, you can't. How are you guys feeling about this? This is, do you understand how to do it?
Yes, I think
Or at least
so.
you understand how to create the box
Gary,
and how to fill in the box.
Are you gonna give us a bunch of stuff on homework that like doesn't make sense?
It will all be like this.
Gary, are you gonna give us another problem that like totally like
Are there going
That totally like confuses us, and then like we all like.
No.
Gary, are there
No.
going to be
Oh my
fractions
God.
on
It's a tried and true homework assignment because it's been used for years. Okay? Yes, Skylar?
Can we be done?
If Washington's applied to this, then, well, then they would each take 6 hours to, like, drive there. Because you can't have, like, somebody that takes 3 hours to drive to another place, and then another person driving who takes 3 hours to get to that other place. It wouldn't take 6 hours, it would only take 3 hours for them to both reach that place. No, it takes 6 hours for them to meet.
It takes 6 hours for them both to do whatever their distance is,
It takes
to meet.
2 hours for them together combined.
Right? Now, one of them, Skylar, one of them will go longer, right? The 80 miles per hour one is going to go farther distance in the amount of time, right? In 6 hours, they will travel from here to here. And in 6 hours, this one will travel from here to here. This is the 55 miles per hour, right? This is 6 hours from here to here, well, yeah, from here to here. And this is 6 hours from here to here. Does that make sense? Because they,
If you're going 80 miles per hour, you're gonna do it shorter in time.
What?
right, but you're gonna go longer distance. I'm showing the distance right here. See what I mean? So that's what's going on. So it is 6 hours total that they're both driving.
They're
Right.
both driving 6 hours, not one driving doing the other driving
Right,
6 hours.
right.
They're both
Each
driving
one of
6
them is driving 6 hours. That's a
It's
good
like
question.
6 hours
Glad you
right
said
here, ready?
that. All right, so the question is, do you feel, I'm gonna turn this off, but do you feel okay, or should I do one more?
No. Let's
Gary,
do
you should
homework.
edit your videos.
Homework, homework.
Okay.
It's